Hello everyone. Today's tutorial about VFX is about water simulation. So let me actually start with some geometry here, and I'm gonna call this guy water emitter, right? And go inside of it. I'm gonna delete the file, and oops, I actually need a file. All right, go to file and load something here. I'm gonna go for my job geometry, which is here. All right, I have mountain. Sorry, not mountain. Fountain here. Except, and there it is. Okay, now it's tilted because it was created in ZBrush, and in ZBrush you don't really have a clear sense of where the up is. Sometimes you probably will be sculpting something that is facing down, facing weird directions, and you don't even know. Anyway, let me translate it and rotate it 90 degrees and negative 90 degrees on the X to make it go straight. Alright, so I'm gonna emit water from this guy, maybe just that top part of it. Right, let me go to S as selection and press 3, actually 4 as face, and go grab some of the faces here and control deselect a few, deselect some of the faces down there and the back faces that I don't really want to select. So I want to emit particles from these faces. Okay, so I'm gonna actually just delete these guys. But instead of deleting these guys, let me actually drag it. Actually, I need that. And let me actually drag it to the side and change the delete operation to delete non-selected. That's gonna give me just that little piece. And then I'm gonna go for a smooth. What this smooth does is basically smoothing this guy out. If you go to the W to see the wireframe and drag the strings up, as you can see, you're basically smoothing it. Alright, now after that, I'm gonna go for a mountain. So what mountain does is basically mounting it. I'll give you some cool variations. I'm gonna tap in add time in the time to make it change over time, like this. Let me turn on real time, and let's take a look, right? Cool. So let me also go down here and create a trail. Now what this trail does is basically I'm going to use it to compute velocity. Alright, and then after that I'm going to create a fluid source. Oops, not compress. This is going to for the some of the cheating way of simplifying cache data size. Fluid source. Okay, fluid source is going to be like this. As you can see, I have velocity in it because I did that using the trail. Alright, now this fluid source will be used to as emitter for my water simulation. Inside of this container settings, I'm going to change initialize to source flip because that's what the flip solver, which is a fluid solver, needs. Okay, so initialize with that, and it should be okay. And oh, one more thing, underneath the deviation size in the scalar volume tab, you can change deviation size to something like smaller if you wanted to go for just a little bit more detailed. And okay, I'm happy with that. I'm gonna create a null here and call this guy emitter. Right. Alright, moving over back to the transform, let me drag out another null and call this guy collider. Okay, so I have two things from the same geometry. One for emitting particles, another one for the collision. One thing I do notice is that my collision geometry is basically overlapping with my mountain. So it would be better to move it a little bit. So I'm gonna drag out from the blast and type in the transform. And drag it here, right? And Let me also turn on the template of the mountain so I can see it. That way I can just drag it forward and make it smaller, and maybe go up back here. Okay. All right. Now that should give me something that is decent enough. All right. Now going out of it, I'm gonna go for a dot network, and instead of this guy, actually let me rename it to water stem. Instead of this guy, I'm gonna go for, first of all, a source volume. Oops. Source volume will be sourcing a volume for me to use, and that source volume will be passed to a flip stopper, and not to the first but the last input. The flip stopper then will have to create a flip object, and then let's do a gravity and drag it over there. Alright, so you can see it's loading something here. That's actually is loading the some of the default fluid objects. I don't really want that, so let me delete that. What I really want to source is the volume I created earlier back in my water emitter, this guy here, or this guy. So I'm gonna go for the source volume and change my volume pass to my emitter here underneath the water emitter. Accept that. Okay. Now let me zoom out. Yeah, as you can see, I don't got anything. The reason being for that, again, is the source volume is trying to source something for smoke. Change that to flip also. Okay, this is gonna actually make it load the particles. If you play the animation, as you can see, it's start to emitting particles and falling down. All right, let me go ahead and create a static object for my geometry. I'm gonna go soft pass and load my collider here, and here dragging from it, I'm gonna create a static solver, and then I'm gonna need a merge that with the flip solver, and drag the gravity there. Alright, let me press L to align them. Now you can see I'm basically now having my geometry imported. If I play the animation, the water should be flowing with it, or flowing on it. Alright, cool. So let's go back to frame 1 and here underneath the flip object I'm gonna change the particle separation. Whoops, not there yet. Go to the guides and particles, change the visualization to particles. So it's gonna actually allow me to visualize the particles. As you can see, they flow down. Now I do have some problem here. As you can see, it's not really colliding with the geometry. Sometimes it intersects. The reason being for that is because the static object now underneath collision, the collision guide is here. You can check that out. As you can see, it's basically colliding with its blue geometry here. If it's easier to see, you can turn off display geometry right here to really see what's going on. Right. So the particles are colliding with this guy. Instead, to crank up the quality of this guy, you can go to the uniform divisions and start doubling that number. So now it's 60. Now you have to go back to frame 1 to update it. Alright, so still not enough. 120. Yeah, getting better. What about 180? Get even better. So yeah, that's basically how you tackle the quality of the collision. I'm gonna settle down for 150 and I'm gonna check that off and go back to display geometries. Now if I go play, as you can see, it's colliding with the geometry, a much better geometry now, so we're getting like better result. Okay, That's it's leaking from the back. I guess if I wanted to, I can create a blocker here to really block it from falling down. But I'm not really worrying about that. So here we have this water fountain going down like that. Now a few things we can talk about here. The first thing is the interaction with other objects. For example, if you wanted to make it interact with like a RBD object, let me just go for something really simple, maybe a sphere here. Control click, grab the sphere and go to collisions, static object. Oops, not there. Not static object, sorry. Actually, the go to the collision rigid body, actually RBD here object. Click on it. Alright, that should make a RBD object for me to simulate with the others. I don't need that merge there. Let me just merge it right here to this merge I have earlier and change the order to rigid body maybe in the middle, I guess. That should be good. Alright, and for the rigid body, I'm gonna move it up. And also, let me go back to the sphere and change the sphere type to polygon, crank up the frequency, go back to this simulation. Alright, now if I start simulating, I'm expecting to see the object falls down, but it's not really falls down. It's like falling down some invisible geometry and start rolling on top of it. Now that invisible geometry is actually what this static object is, but we have changed this to a really high quality geometry right now. Why is it not doing that? Because this is for RBD solver, and partly our RBD object is using, if you go to the rigid body solver, it's using bullet. So we have to also go to bullet here and tell it to use a concave geometry. That's gonna make it really collide with the geometry. And now it should be falling down properly. Let's take a look. Alright, now it's colliding with the geometry nicely. As you can see, the particles does kind of like interact with this ball. You can see they wrap around the ball, and the ball is like, because of the gravity, is being dragged inwards a little bit, and the water is wrapping around it. So everything seems to be reasonable, but one of the things is a little weird is that the water is like never really have any force applied on the ball. We can actually improve that by go to the ball again and maybe just make it half as big. Go back to the water simulation and let's do it again. As you can see, the ball falls down, no problem, hits the water, and it just stays there. I guess it's not capable of falling back down. So let me go back, falling down. So let me go here and maybe just drag it to, you know, maybe a little bit above here and simulate. As you can see, it is kind of like affecting the particle, but the particle doesn't really push it anywhere else. You can see that splash being pushed by the ball. Now the reason being for that is because, first of all, the merge is using left to affect right if you probably want to use mutual. Another problem is probably the ball is too heavy, so let's go to the physical thing and change the density on the sphere object to maybe 100. And the water, if you look at the flip object, it's underneath the physical thing. You can see it's 1000 as density. So water should be having more mass now per unit than this the material of the ball. Right. Now you would expect that that's gonna give the water some chance to push the ball around, but still you can see the ball doesn't really care about how the water moves. it's gonna push the water around, but the water have no strength back to the ball. The reason being for that is also because the flip solver here underneath velocity motion and solver, you have this feedback skill. If you change that back to 1, up to 1, it's going to actually apply feedback force to any object interacts with it. So now when you see the ball falls down, you can see it's basically now being affected by the water and being pushed by the water. Right. I guess there's just a lot of water emitting from there, so it's being pushed up, almost like floating. Okay, so yeah, so that's one of the little things I think was mentioning about interaction with fluid particle, because you have to really enable all these things to to make sure that everything works. Cool. So I don't really want it to interact with dynamic object. I just want it to flow on the surface of the model, right? Then that's something we already have. All right, so that's gonna be the first part of this tutorial. All we talk about is how you set up physics things and make some interactions and some details about collision quality here. Okay, so in the next one, we're gonna go ahead and do some tweaking of the fluid. So see you next.